Okay, everyone. So in this video, we're going to talk about acids and bases, and there are three definitions of acids and bases. The oldest one is by a guy named Arrhenius. The most recent one is a guy named Lewis, and the one in the middle was actually two scientists named Bronsted and Lowry. Those were their last names, and their definitions are named after them. Now, there are three definitions, but Arrhenius and Bronsted-Lowry are the only ones that you need to learn. So in this video, we're going to kind of deep dive into both of those and the implications on what they define as being an acid and a base. So if we focus first on Arrhenius, because that definition is the oldest, Arrhenius defined an acid as something that when it dissociates in water is going to produce H plus ions. And so remember that a dissociation means when the compound is put into the solution that it breaks apart into its ions. And so a base dissociates as well, but it produces hydroxide ions or OH minus ions. And so if we look at some examples, when HNO3, which by the way, just as a reminder, all compounds that start with H are acids, literally every single one of them. So HNO3 is an acid, and when it dissociates, it's going to break apart into H plus and NO3 minus. Now, just as a reminder from first semester, NO3 minus is a polyatomic ion. Okay, so the nitrogen and oxygen are covalently bonded, so they don't actually break apart, but together they have an overall negative charge, which is why this is still ionic. So it kind of stays together. Now, when NaOH dissociates, it dissociates into Na with a positive 1 charge, so our sodium ion, and our hydroxide ion, which is OH, with a negative 1 charge. These OH minus is also a polyatomic ion. So Arrhenius defined acids and bases based on what they produced when they dissociated into water. Acids produce H+, bases produce hydroxide ions. Now, with this, acids and bases are opposites of each other, and so neutralization is a reaction when an Arrhenius acids and base react to form water and salt. So the way that looks, for example, if we had HCl, which is hydrochloric acid, plus sodium hydroxide. This is a very common reaction. If we have HCl and sodium hydroxide, we know that hydrochloric acid starts with an H, so this is our acid. And sodium hydroxide has that OH in it, so that means it is our base. And when they react, what happens is this is a double replacement reaction. So the sodium and the hydrogen are going to swap places. Remember from first semester, this is a wife swap reaction. So this is a double replacement. And it's a special double replacement simply because it is also an acid-base reaction. And so when the sodium and the hydrogen swap places, they produce NaCl, which is salt, and it also produces HOH, which otherwise written is H2O. So that is our water. Now the key thing to remember here is that salt is really any ionic compound. I know that we say NaCl is salt, but what we mean by that is table salt. So if you had, for example, HNO3, so nitric acid, plus magnesium hydroxide. Okay, when this reacts, it would produce magnesium nitrate. One thing to remember is that magnesium is in column number 2, so it has a +2 charge, OH has a -1 charge, H has a +1 charge, and NO3 has a -1 charge. So when they swap places, the magnesium with a +2 charge and the NO3 with a -1 charge. In order to balance out the charges, you'll need 2 nitrates. But that, again, is just a real quick refresher from first semester. So it'll produce magnesium nitrate and HOH, which again is H2O. So this would also be considered a salt because it's an ionic compound. It's just magnesium nitrate. It's basically all the elements together that aren't the hydrogen and the oxygen that are making up the water and that are being dissociated. So yeah, it's your 2 ions that are not really doing much. These are the main focus in a acid-base reaction. So that's a neutralization reaction, which is just a double replacement. And it's all about which one has hydrogen, which one has hydroxide. Now, this was a really great definition for acids and bases for a really long time. And Arrhenius characterized this, said, hey, a lot of acids behave this way and a lot of bases behave this way. But Bronsted and Lowrey almost simultaneously came up with their definition, so we kind of credit it to both of them. And because they came up with it literally almost at the exact same time, completely apart from each other. They didn't really collaborate on it. And what they discovered there were bases, really, that behaved, or there were chemicals that behaved just like bases, but really weren't included because they didn't have hydroxide in them. And so they defined Arrhenius's acid, they just kind of expanded it a little bit. So they said that an acid is really something that is going to donate a proton. Now, what we mean by a proton is literally H+. So remember that hydrogen has an atomic number of 1, so it has 1 proton, and a mass of 1, which means it has 0 neutrons, and when it's neutral, it has 1 electron. But most of the time, its electron gets stolen, and so that means that there's literally only a proton left. So H+ is literally a single proton. And they said that the acid is going to donate this proton, and the base is going to accept or receive the proton. So they kind of work as a partnership. And we can see that in a couple of different ways. So if HNO3 donates its H+, what happens is it has NO3 with a -1 charge left behind. Whereas ammonia, which is NH3, keep in mind, ammonia would not typically be considered a base because it does not have hydroxide in it. But what it can do is it can receive that H+ ion. And when it does that, it becomes NH4 with a +1 charge. So you can see it gained that extra hydrogen. And we say that what it produces is its conjugate pair. Pair or conjugate means partner, and so its partner is going to be the opposite. So if this is an acid, then this would be the conjugate base. If ammonia is the base, then that means NH4 + 1, or ammonium, would be its conjugate acid. And so this can be written in a chemical reaction that looks like this. Acid plus base produces conjugate acid plus conjugate base. And let's go ahead and write out those definitions. Conjugate base is what is left behind when the acid donates that proton, and the conjugate acid is what is left behind when the base accepts the H+. And it's not really left behind, I guess it's more produced. So as an example, if we have, again, HCl plus NH3 producing Cl minus plus NH4. We know that this starts with H, so it has to be our acid. NH3 must be our base. So what we do is we say, okay, we know if this is our acid, it's going to donate an H+, which means its partner has to be something that's produced. So both of these are conjugates. Okay, your conjugate acid and your conjugate base always have to be on the product side of your reaction. And what we look for is we look for what is similar to the acid but missing a hydrogen, and we see the Cl minus. It's exactly like the acid except it's missing a hydrogen and it's one has a negative charge. So that would mean this is the conjugate base. Whereas NH4, by process of elimination, has to be our conjugate acid. And we can see that because NH3, if it's the base, that means it has to accept the H+, and we can see that it gained that additional one with that 4 there. And so the key thing to keep in mind is that these double arrows here mean that the reaction is reversible. So the chlorine and the NH4, the ammonium, can react and produce the HCl and the ammonia, and they can reverse and go back. They can kind of go back and forth, back and forth. But when you're labeling, this is kind of how you would identify what is your acid, what is your base, what is your conjugate acid, what is your conjugate base. And one thing to keep in mind is that water is actually an interesting compound when we think about acids and bases, because water is amphoteric. Now, this is a vocabulary word that you're going to have to know. And this means that it can act as an acid or a base. It can be both. So if you look at water with the lens of an Arrhenius definition, when water dissociates, which I know it sounds silly to dissolve water in water, but when water is all by itself, it has a reaction that's continually happening where water is splitting apart and reforming constantly. And when it splits apart and dissociates, it dissociates into hydrogen and hydroxide. And so we see that this H+ gives it the definition of an acid, but the OH- is the definition of a base. So depending on what else you're mixing with the water, it can change how its behavior. It can do both. Now, if you look at it through the lens of a Bronsted-Lowry definition, the Bronsted-Lowry definition says that an acid is going to donate a hydrogen. Well, if we look at H2O and it donates our H+, then what it leaves behind is hydroxide ion, OH-. But if we look at it as a base, H2O can actually also accept a third hydrogen, and that is because it has those lone pair of electrons around hydrogen, and it becomes H3O+. Now, this is called the hydronium ion, and you definitely need to know this. And one thing that's important to note is that H3O+ and H+, so the hydronium ion and the proton, are used interchangeably, meaning that we use them to mean the exact same thing. So H3O+ is equal to H+. It's literally the same thing. We're just dropping off the water aspect of it. And so you're going to want to know that these brackets, we'll use them often. Those mean your concentration in molarity. So if you see brackets around H3O+, that means it's the molar concentration of H3O+, of our hydronium ion, or the concentration of our protons. And so if you see that H+ concentration is equal to 0.5 m, that means that the concentration of our proton or our H plus, is 0.5 molar, or 0.5 moles per liter. So that means you have 0.5 moles of H plus for every liter of solution. And so this is kind of the basic definition of Arrhenius and Bronsted-Lowry with conjugate acids, bases, neutralization. It's probably one of the most important videos to really watch and understand. So if you have questions, drop a question in the comments and let me know.